And now it's time for a return to beneath the planet of the models. Network models, that is. Sorry about that. This particular model, while important, just as your OSI and TCP/IP models are, it does not map to them. This model is not for the same purpose. This is strictly a switching model, which is why we call it the Cisco three-layer switching model. The ultimate, the name is the recipe name. Because not all switches are alike. You know, you've got switches that can do a perfectly good job in a small network, but if you took that same switch and you put it in the middle of an enterprise network, I mean, it's practically going to explode. It's not going to be able to handle the workload. So when we have a larger switched network, when we have a lot of switches, we've got to have a way to identify and say, here's where we should put our powerhouse switches. Here's where we should put our less powerful switches. And also, we've got a little something, I want to introduce this term to you. It's QoS, quality of service. And it's an important part of networking. It's not on your CCENT or CCNA exams. But the key with QoS is what you're doing is identifying traffic that is more important and perhaps less important. And you're saying, okay, these packets have to go through no matter what. And you identify other kinds of packets where you say, if the network is overloaded and we have to start dropping packets, these are the first ones we want to drop. So QoS is an important part of networking, but you don't want to be doing that on the switches that are in the middle of your network, because QoS, I mean, that's a load on your switch. You want to do that as close to the end users as you possibly can. That's another reason this model really helps. Now, when you first hear the term campus network, first thing I think of is a college, university, something like that. Well, you could find a campus network there, but this term is used to describe any network that connects physically close buildings. So we're not talking anything like, you got one network in Los Angeles, one in Dallas, and they're a campus network. That would be a really big campus. That's not how it works. So the Cisco switching model, let's take a look at it now. It consists of three layers, as you've probably guessed by now: core, distribution, and access. The very name, of course, core, tells you that's at the middle of these three circles. It's the innermost circle. Distribution is your middle layer, and access is your outside layer. Your access switches are those closest to the end users. Good way to remember that is how your end users access the network. Now, the distribution switches, those are the ones in the middle, and they connect your access layer switches to your core layer switches, and then finally in the center, you do have those core switches. That's where you don't want to be performing things like quality of service. You want to do QoS and any kind of traffic filtering or marking. The closer you do that to your end user, the better off you are, because it's more effective that way. Your powerhouse switches that are in your core, the only thing you want those switches to do is switching. You don't want them doing QoS. You don't want them doing anything else. You want them doing switching. Now, in the example I'm going to show you here, here's an access distribution core setup, and you've got two different buildings. And traffic that goes through a PC in building 1 to a PC in building 2, it has to go through at least one switch in each layer. And notice again that your end users, your PCs, are connected only to access layer switches. Now, there's one other reason we love a design like this. It gives us plenty of redundancy. And one thing we're always trying to avoid, and you experienced networkers know what I'm about to say, we always want to avoid that single point of failure. There's nothing worse than one link going down and 50 people can't get to the other building. 50 people can't access the data they want. We always want another path ready and available from point A to point B whenever we can get it. So if the best path fails, then the next best path is waiting for us. And we're going to talk about redundancy throughout the routing protocol section and our switch protocol section as well. That's what we want. Redundancy, it's just a fancy way of saying we've got a backup plan. And in networking, just like in life, you always got to have a plan B. And in this case, that B stands for backup, because we will take as many backup plans as we can get. Now, we do need a process, though, that allows us to pick the fastest path between switches while having those backup paths standing by. And we do have that, the Spanning Tree Protocol, STP. It's going to be your first protocol. And you're going to be introduced to that in the very next section of this course. Right now, I want to introduce you to another vital switching topic, and that is fundamental switch security. Security, obviously, a huge part of today's networks, and it's not going anywhere anytime soon. The more security you go on to learn, whether it's CompTIA Security Plus for the fundamentals, whether it's Cisco-centric with a CCNA security, the more security knowledge you have, the better off you are. The fundamentals of security, they don't sound that exciting, but they really can prevent your casual attacks. One of them is just to make sure your switches are locked up. This isn't as prevalent as it used to be, but say 5 to 10 years ago, I was amazed at how many server rooms I could still walk into without a badge, without a pass. Just, the old thing, just look like you know where you're going. And, your server room should obviously be locked. Now, your cabinet should be secured as well. I know that's only going to happen in a perfect world, but keep at least one locked door between non-networking personnel and your switches at all times. Another trick I want to show you, not really a trick, but it's an often overlooked security feature, and that's using your unused VLANs for security. Now, we've talked about VLANs, we've configured them, we're going to configure them some more. But you can also use an unused VLAN as kind of a security feature, because Cisco switch ports on a lot of the models have some defaults that frankly are very undesirable. One of them is that they're open. You'll notice when we were doing that previous lab with the VLANs that I didn't have to do anything to open the switch ports. The switch ports were already open. On routers, they're actually shut by default. So to have the door open, so to speak, just like that, it's not really desirable. It's not what we want. Now, Cisco switch ports on many models, again, not everyone. On the 2960s, they're not doing this, but the 2950s, they are. They're actively attempting to trunk. And that means that they're available for connecting to another switch. Let's say if I take two 2950 Cisco switches, a very popular lab switch, if you connect them with a crossover cable, the trunk's going to come up immediately, this inner switch connection. I don't have to do anything else. I don't even have to configure it. So that's not really a desirable thing either, because we could have a rogue switch introduced to our network. That happens. Somebody could get a switch physically in that room, connect it to another switch, and all of a sudden they're in your network. Something else, undesirable default we saw, all ports are in VLAN 1 by default, and everybody knows that. So these are three defaults we may want to change. What I would do here, what I just like to do, period, is close unused ports with the shutdown command. If you do that, then everything else here is kind of moot. I just like to shut down unused ports. You can also prevent the port from trunking with a command called switch port mode access. And that makes a port an access port. It can only belong to one VLAN and it can't trunk. And you will see that in action in the trunking section. So if trunking is new to you and you're not grasping that immediately, don't worry about it. You haven't seen it yet, but you will. I wanted to mention it here with the other security tips. You can also create another VLAN that you're not going to use for anything else and put all of your unused ports into that VLAN. Nothing wrong with that at all. Again, I just like to shut the ports down, but these are three really good tips for increasing your switch's security. The next one here is one we're going to do plenty of lab work with, and that's port security. Let's talk about that for just a moment. In a real-world scenario here that I've bumped into more than once, and you're very likely to bump into, if not on your exam, certainly in the real world. We've learned how the switch builds the MAC table. We know the deal. And here's another reason that I'm mentioning this again, that the switch looks at that source MAC address before anything else. And when we talked about, the switch uses that value to build the MAC address table, but I did mention there were other reasons it does that. And port security is one of those reasons. That behavior of examining the source MAC address first, that makes port security possible, as you're about to see. Now, if you have end users that use laptops in the field and then they come in and they just plug it in and they're using it in their office, which is pretty common, this feature can be of really high value. And this is something, again, that real world scenario that's happened to me and plenty of you as well. Let's say that you have someone, doesn't have to be a vice president, but it probably is, that uses a laptop with a MAC address of all Bs.
And she suspects that someone else is using her office while she's gone. If you ever worked in a real estate office, you know this can happen. Believe me. And she wants to make sure that no one else can go in her office and hit the network. Or maybe she just comes in one day and says, hey, just in case, I don't want anybody else to ever get through the network, through that port, or from my office except me. We can actually do this with port security. And here is the theory of how it works, and then we're actually going to configure it live. The switch is going to look at that source MAC address first, as it always does. If the incoming source MAC address is considered secure, the user will be able to access the network, and everything just goes on as normal. Your user doesn't even know this is going on. Now, if the source MAC is considered non-secure, the port will take one of several actions, more on that in a moment. And what happens here is that the source MAC address of the incoming frame, it really acts as a password. We don't really call it a password that often, but that's just what it is. And what happens then, again, it'll take one of several actions, but whichever action we configure it to take, that person is not going to be able to access the network through that port. So it's very powerful stuff. Port security is not on by default, and it's got plenty of options. So we want to see all those options in action. Got a couple labs for you on that, and we will start that on the very next video. I'll see you there.